All right, so we are graphing quadratics in standard form. Oh. All right, everybody has a sheet now, right? Yes, okay, great.
My friends were doing it a couple days ago.
Better get caught up. All right, so let's take a look. Ask me for what? I do have one if you need one. Oh, no. Oh, no.
Is it frozen?
Well, there's so many people out today, so I want to make sure that I do get it. So hold that thought.
Freaky chic and fun.
Wait for me.
Will you wiggle your hand under the camera?
Where's the pencil?
Wiggle your hand under the camera.
Who said that?
This kid.
Thank you.
I think nobody is, but-
No,
Okay,
it's
good.
It's usually over.
It's not supposed to be really.
Yeah.
Let's
Pick
see.
one out of that cup.
Yeah, we don't know, bro. 1 million.
That one has no lid. I'll pick another.
Oh.
Okay, now I think we're ready. All right, so let's take a look at what they are asking us to find. There's a whole bunch of info that we need to find for each one. So we need to tell if the quadratic is up or down. We need to find the vertex, the axis of symmetry, the y-intercept, x-intercept, and we're gonna graph it. Oh my gosh. Turns out a lot of this stuff you already know. You know how to tell, well, actually, let's back it up. A quadratic. First of all, what even are those? What's a quadratic? Say it again.
Evil.
Ah, evil. What are they really? They're not so bad. If you're looking at an equation, how do you know it's a quadratic? Because it has x squared. That's all it is. So these are just things with x squareds in them. So don't get all hung up on the vocab, right? It's just the thing that has an x squared in it and no higher exponent, right? It doesn't also have an x cubed or something. X squared is the highest we have. That's what we call a quadratic. And when we graph them, what do they all look like? Parabolas. They all make a U shape. All of them. So if you are going to graph a quadratic, it's going to be a parabola. Now, you can change that U shape. You can make it real narrow. You can make it real wide. You can flip it upside down. But it's always going to be a U shape or a U shape upside down for a quadratic, right? Okay, cool. You know how to tell if it's up like a cup or down like a frown. How? Yes, you're basically looking at your value of A, right? If A is a positive number, it's going to be up like a cup. If A is negative, it's going to be down like a frown. So if A is positive, it's up. If negative, it's going to be down. That's super easy, right? So if you are ever taking a multiple choice test or anything, and they have you graphing a quadratic, you could, you know, just like immediately if it should be up or down. So you could very easily eliminate some choices that way. All right, let's talk about the other ones you probably already know. You know how to find the y-intercept. How do you find the y-intercept of anything? Yes, exactly. All you do for that is plug in 0 for x. And solve for y. Now, let me ask you this question. How many times can a parabola, a U shape, cross the y-axis? Once, you say? Try and draw it. Draw anywhere, just like over on, draw yourself a coordinate plane, and then draw yourself some different parabolas. See how many times it crosses the y-axis. That's the one that's going up and down, right? So I could draw one like this. that parabola only hit one time. Can I draw it another way? You could do something like this. You could try and draw a parabola over here. But does this one ever cross the y-axis? Yes. Why? Because remember, this keeps going forever. So eventually it's going to run into that y-axis. It's just going to happen somewhere like way that I just can't see it. Is there a way? Now, you can't take the U shape and turn it sideways. That's not allowed because then it's not a function anymore. So it's always a U shape or an upside down U shape. Is there any way that you can think of that you would hit the y-axis more than once? Nope. You are always guaranteed one y-intercept. Every single parabola has one y-intercept. All of them do. And only one. Okay, so plug in 0 for x and solve for y. There's only one y-intercept. That's it. That's all you can ever get. That's different from the x-intercepts. You just took a quiz on finding the x-intercepts. That's what you do when you solve a quadratic. So if you have a y in your equation, remember how we just replace it with a 0, because at the x-intercepts, isn't y equal to 0? Right? Think about it. Where something crosses the x-axis, the y value is always 0 there. Okay, so to find the x-intercepts, I'm going to plug in 0 for y. And solve. Now, how you solve is up to you. You have 4 different ways: square rooting, factoring, completing the square, quad formula. So I'll say solve by either square rooting, factoring, complete the square, or quad formula. All right, so that is literally what your quiz was yesterday. So you all know how to find the x-intercepts. Also, remember that review one that we did where you went around the room and on the back was a chart and you picked like which way you would solve that one? That's exactly what you're doing here. So if you plug in a 0 for y, and now you get to solve it however you want. But you need to remember, not every quadratic can be factored. So you can't just only do factoring. You don't want to do every single problem with quad formula either. You're going to be here all day. So it's helpful to know like which one makes the most sense at what time. All right, so those things we already know. And then luckily, the vertex and the axis of symmetry are kind of tied to each other. Do you remember from Algebra 1 how to find the vertex? Just from the formula? So like if you looked at number 1, do you remember how to figure out what the vertex is of this? You got to do a little bit of math, but it's not that bad. Anybody remember? That's okay, I'll tell you. All you're going to do to find the vertex is, so the vertex is a coordinate, right? X, y. To find the x coordinate, you do negative b over 2a, which sounds super random and weird, but isn't it part of the quadratic formula? If you were to look at the quadratic formula and just not, hold on. Look how cool this is, right? So here's the quadratic formula. If you literally just ignore this whole part, look, negative b over 2a. So you don't even have to like learn something new. You just need to know, oh, it's just the quadratic formula, but I ignore this whole piece. Negative b over 2a. That gets you the x coordinate of the vertex.
Pardon the interruption. Students going on the Warrior Ice Arena field trip should report to the main lobby at this time. Again, that's students going on the Warrior Ice Arena field trip. Thank you.
So x is negative b over 2a, but then how do you find the y? Does anybody remember? Once you have that x, let's say x comes out, you do negative b over 2a, and it's just a number, right? Let's say it's 2. How would I then find out what y is? Exactly. I just take the answer that I got and I plug it back into the equation and see what comes out. So, I mean, the way that I want to write it is as f of negative b over 2a. So that's taking that answer and plugging it back into the function, but I feel like that's just going to confuse you more. Or take that answer and plug into equation. Oh, let's say take answer for x. And then the axis of symmetry, if you know the vertex, you know the axis of symmetry. It's super easy. All it is literally you have to write x equals because it's a line, and you just write whatever the x value is of your vertex. So it's literally just x equals whatever negative b over 2a was. Sorry, I didn't leave you a ton of space here. I should have, but I didn't. But that's it. So that's how you find all of these pieces. Now, let's see if we can do it. It doesn't really matter in which order you do these things. I don't know. We'll just go in order the first time. Why not? So let's do number 1 together. And then obviously we're going to graph it when we're done. So let's see. Everybody's okay so far? All right, let's try it. So letter A, I'm supposed to tell if this thing is up or down. It's up, right? Because A is positive. So this thing is going to be up. So when I make my graph, I better make sure that it really is facing upwards. Okay, cool. 2, find the vertex. So this is where I do negative b over 2a. So it might be helpful. I'm going to list my A, B, and C just so I have them. A is 2, B is negative 12, and C is 20. Right? So let's do negative b over 2a. So that's going to get me positive 12 over 2 times a is 2. So I get 12 over 4, which is just 3, right? That means my vertex is at 3 comma something. You with me so far? You see where how I did that? Negative b over 2a. It came out with a 3. Cool. So my vertex is at 3 comma. Now all I have to do is take 3 and plug it into the original equation to see what comes out for y. So now plug 3 into equation. So 2 times 3 squared minus 12 times 3 plus 20. Let's see what comes out when I do that. 18 minus 36 plus 20 is that 2? Double check me. Am I right? Is it 2? Yeah. Okay, cool. Now I know where my vertex is. So now I know it's at 3 comma 2. Yay. So in fact, if I want to put a dot at 3 comma 2, I already have my first point on this parabola. Yay. You know what? I shouldn't have done this one first. Darn it. Oh well, it's okay. The axis of symmetry. Do you know what I mean when I'm saying axis of symmetry or no? I'm going to assume that some of you have no idea. So let me tell you. When you are looking at a parabola, right? Remember, we have a couple of pieces. It's always some kind of a U shape. Your lowest point or the highest if it's upside down. That's what we call the vertex, right? And then the axis of symmetry is just a vertical line that runs right through the vertex. That's the line, that line we call the axis of symmetry. It's just like when you were in elementary school and you were doing lines of symmetry and you had like a butterfly and you drew the line, you fold it over, it matches. Everything on this side is exactly mirrored over to this side. So you get to, I love parabolas because it's a perpetual buy one, get one free sale. If you find a point over here, you get to mirror it back over here. You don't even have to do the math. It's always reflected equally on the other side. So all we need to give is the equation of that vertical line. Well, aren't vertical lines, according to Hoy-Vux, aren't they just x equals some number? Right? Isn't that just the equation of a vertical line? X equals whatever the number is. Well, friends, if I'm going to have a vertical line that runs right through the vertex, wouldn't it just be x equals 3? It's just whatever this number is. But you have to write x equals. You can't just write 3 because 3 doesn't mean anything. But x equals 3, that's a line. And there it is. All righty. And let's see, what's next? Oh, the y-intercept. So according to this, it says plug in 0 for x and solve for y. Well, that's pretty easy. If you plug in 0 for x, what comes out? 20 in this case. So that was easy enough. So if I plug in 0 for x, I get out 20. Unfortunately, that's way too far off my grid. So too bad, so sad. But normally I'd be able to plot that. All right. And then E, the x-intercepts. So we're just going to, this is literally just what you did on your quiz yesterday. Replace y with a 0. And now you're going to solve this quadratic. So let's see, what could I do to solve this thing? Pretend this is a quiz question from yesterday. And it's, you get, oh, whoa. Well, I guess you got to pretend there was another section where it was like, hey, solve this any way you want. Well, I can't solve this by square rooting because I have an x term. So I'm going to try and factor it. I can always pull out a GCF. I should do that. In fact, couldn't I just divide both sides by 2 and get rid of it? Let's do that. Let's make our lives easier. I can divide this side by 2 and divide this side by 2. So I get 0 equals x squared minus 6x plus 10. And now I'm going to see if I can keep factoring. Are there factors of 10 that add to be -6? No, darn it. So I can't solve this one by factoring. That's okay. This would be really nice to do what with? You could do quadratic, but I think doing complete the square would be really easy because A is 1 and B is even. So it wouldn't be that bad. But I mean, it's personal preference. So if you prefer the quadratic formula, you go for it. But if you recognize, oh yeah, I can just do, I'm going to minus the 10 to the other side. Half of that is -3 squared is 9. So I'll add 9 to both sides. Factor, simplify, square roots. Add that 3 back over. So this thing, because my answer has an imaginary number in it, what does that tell you about the graph? Say it again. It's never going to touch the x-axis. Exactly. Which makes sense, right? If I go back and I kind of look at where I was, if that's the vertex, whoa, sorry. There's my vertex, and we already said it's going to be up like a cup. I knew before I even solved that my answer was going to have an imaginary number in it. Because how could a U shape going up, if the vertex is already up here, it's never going to touch the x-axis. Anyway, so how do we get the rest of the graph? Well, this is why I shouldn't have started with this one. I should have started one where A was 1, but I didn't, but that's okay. So what you can always do is you can plug in points. So if I plug in 4, right, and I just do the math out real quick, I'll grab a calculator. So if I were to plug in 4, that'd be 2 times 16 minus 12 times 4 is 48 plus 20. I get out positive 4. So when I plugged in 4, I get out 4. But check this out, buy one, get one free sale. Look. You get to just mirror it over. I'm going to show you a faster way in a few minutes, but I just wanted you to see where these numbers are coming from. You might do one more step out, like plug in a 5, see what that gets you, and then mirror it on the other side. So if I plug in 5 up in the original, that would be 2 times 25, which is 50, minus 12 times 5 is 60, plus 20. What does that get us? 10. So when I plug in 5, I'm getting out 10. But I did the work for this one. I get this one for free. All right. And then I just connect with a nice smooth curve. And there you have it, friends, a beautiful parabola that you have graphed. Isn't that one nice? Yes.
So you don't even have to find the x-intercept, like you could just plug in and check once you get the vertex.
Well, normally, if your x-intercepts, right? So we did them here. So here's our x-intercepts. If they were not like numbers that weren't imaginary, that would give me 2 more points and I wouldn't have to plug extras in. You know what I mean?
Yeah, but not like that.
Of what?
Like any of the
Good thing that I'm after school to help get you better at it. Okay,
How do we get those numbers again?
which ones?
Like the ones with the graph.
Oh, so if you don't, if you still, yeah, so if you only have a vertex and you need other points, you literally just, so my vertex was at 3. So you just go 1 space away. So I just plugged in 4 into the original equation.
Oh,
Yep, and then I go 1 more space out. In this case, it was a 5. So wherever the vertex is, you just go 1 space to the right. You could go to the left too if you wanted. Oh yeah, I should have done that. That was silly. These are smaller numbers. I could have plugged in 2 and 1. What was I thinking?
so it's like the original, like the first, like the actual question.
Yes, exactly. Yep. But hopefully by the time you get to the graphing, you have enough information that you may not even need to plug in extra numbers. So let me pick another one that's going to be more like what I want it to be. Do I have any where A is just 1? Well, I don't want it to be -1 either. I wonder, maybe I'll change what 3 is because I want to do one where just A is 1. You know what? Let's, oh, and then the graph is all weird. Let's cross out 4. I'm going to give you a new problem for 4. So cross that out. Let me find one that I make real quick. Let's do x squared. How about let's do, I gotta change this a little bit, sorry. Well, let's try that. Oh, it's too far. Sorry. Plus. Hi.
Hey, what's that you told me the other day?
Which one?
I don't know. Giggled afterwards.
So
There were so many. I was reading him your guys' jokes.
no, I don't think it was one they came up with. It was 2 days ago. I don't even remember.
Oh, the best gift I ever got?
I don't know. Tell it to me.
Do you want to know the best gift I ever got?
What?
A broken drum. You can't beat that.
I like that one. That's funny.
Today's joke was, my rich neighbor crashed his car into a tree because he wanted to see how the Mercedes Benz. Some of them are a stretch.
You
but-
guys have a favorite word? I have a favorite word. Anybody have fun at it? What's your favorite word? Defenestration. What is it? Defenestration. Like, I'm cool. Or what? Because it rolls off my tongue.
All right, I think I have one now. Yes, okay, this is what I want. All right, so our new equation for 4 is going to be x squared minus 10x plus 24. All right, so cross out your number 4, put this new one in. And let's go through these steps together. All right, is this thing going to be up or down? Up for sure. Let's find the vertex. So to do the vertex, we got to do that negative b over 2a. So everybody go ahead and find that number. Did you get 5? Negative b over 2a, yeah, everybody got 5? So that's half of our answer, right? So now we know it's going to be a 5 comma something. How do you find the something? Exactly. Go back to your original equation and pop in 5 real quick. So that's 25 minus 50 plus 24. Which is -1. Everybody get that? That's how we get there. So now I know where my vertex is. It's at 5, -1. So I'm going to put a dot on my graph. I know this thing is going to be up like a cup. So I know it's going to cross the x-axis twice, right? I can already tell these things because my vertex is down here and it's going upwards. All right, let's try. Once you know the vertex, you know the axis of symmetry. What do I write as my answer? What'd you say? What do I write as the vertex of symmetry? The axis of symmetry. You got to write x equals 5. You need the x equals part because then it's an equation of a line. If you just write 5, 5 doesn't mean anything, but that is a line. So if it helps you, if you want to just draw yourself a little dotted line right there, you can. You don't need it. It's not part of the graph, but if it helps you visualize, great. What's D? The y-intercept. Let's find that. If you plug in 0 for x, what comes out for y? Go into your original equation. If you plug in 0, what comes out for y?
6.
24, right? 0 squared minus 0 plus 24 is 24. So unfortunately, that's off my graph. Too bad, so sad. Sometimes it will be, sometimes it won't be. But check this out. Let's go to find our x-intercepts. So I'm going to x squared minus 10x plus 24. Let's try and solve this one by factoring. Are there factors of 24 that has to be -10? Yeah, and they're both negative, right? -4 and -6. So there's my factors. When you solve this thing though, what are your actual answers? +4 and +6. So that means that this parabola is crossing the x-axis at those two locations. So I get one dot at 4 and one dot at 6, which makes sense because they should mirror each other, right? Oh my gosh. So now all you really need to make a parabola, it's great if you have 5 points in total. I have 3 already. If my y-intercept wasn't so far off the grid, I'd have that one too, and I wouldn't even need any more. But it's too far off. So what I would do is I already know what the value is at 5, 6, and at 4. Let's just plug in one more. You could either plug in 7 or you can plug in 3. I plug in 3, right? Because it's easier. So if you take 3 and plug it into the original, 9 minus 30 plus 24, what is that? I get 3. So when I plug in 3, I get out 3. So I got it 1 here. I get to mirror it over here. Now, I told you that I would show you a shortcut. Are you ready? You might already know it. I don't know. When A is 1, look at how the points go. From your vertex, the next point is always up 1 over 1. The next point is up 3 over 1. And if you went even further, the next one will be up 5. It keeps going up by the odds. 1, 3, 5, 7, 9, if you kept going, right? But it's always that pattern. So if A is equal to 1, oh God. Go does not have a U on it. Go up 1, then up 3, then 5, if you can get that far. You go up 1, you go up 3, you go up 5. So you don't even have to plug in the points anymore. If you know the pattern, if A is 1, that's all I'm doing. Up 1, up 3, and then up 5 if I could get there. Okay, cool. So this pattern only works when A is 1? No. You just have to adjust it if the value of A is anything else. Let's rewind back to number 1. Here, A was 2, right? Let's get the original back. There it is. And look at what I did. I went up 2, and then I went up 1, 2, 3, 4, 5, 6. So what do you think I did to that pattern to get this pattern? You just multiply it all by 2. So you mean to tell me if I know the pattern when A is 1, up 3, up 5. If now A is 2, I just take all those numbers and I times them by 2. So I just go up 2, up 6, and then if I could. So if A were 3, wouldn't I be going up 3? Then instead of going up 3, I'd actually be going up 9, right? You just take whatever the pattern is and multiply it by what A is. Yeah.
What about for negatives?
Same thing. If it's negative, I would just multiply by a -1. So I'd go down 1, down 3, down 5. So for like number 3, once you find the vertex, you just multiply your pattern by a -1. Down 1, down 3, down 5. Even if it's a fraction, if it's a half, it's a little bit inconvenient, but whatever. So instead of 135, I'd go 1. I'm sorry, I'd go a half, 1 1/2, 2 1/2. Isn't that fascinating? I knew you would like that. Because it makes the workload so fast. So let's see. Let's do 6 together real quick. Is this thing up or down? Up. Find the vertex, everybody. -b over 2a. Did you get 4 when you did -b over 2a? When you plug 4 back in, did anybody do it yet? I have it, but I want you to have it. You can always use a calculator. You don't have to do it all in your head. Have the calculator do all those numbers for you. I got -4 as well. So cool. Now I know where my vertex is for -4. So if I'm just graphing this, right, before I even find all the other pieces, I know what to do it. See if you can do it. Take our pattern of 1, 3, 5. And what am I going to do since A is 3? So normally I go 1, 3, 5. But what am I going to do this time? I'm multiplying all of these by 3. So I'm really going to go up 3, up 9, and up 15 if I could, but I probably can't. So I don't even know how much I'm going to get on there. But from here, this dot, I'm going to go up 3 over 1 and mirror it over to the other side, right? Buy one, get one free. And now from this point, I can go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. Mirror that to the other side. So cool. You can always check yourself, right? If you're like, am I actually doing this right? Plug in 2 and see if it actually comes out with an 8, for example. Take any of the points you just made and make sure that they're right. I'm going to. You never know. So 3 times 4 minus 42 plus 44. Oh dear. What did I do wrong? Oh gosh, I did something wrong.
Your points are a lot higher than mine.
Did I count wrong?
I think you counted.
3 times.
I think you counted from the other points.
That's right. Hold on. Why did I mess up here? Oh, I forgot to times it by 2. 3 times 4 minus 48 plus 44. Yeah, I'm right. You count from your last dot. So I go up 3 over 1, and then the next one from that one, I go up 9 over 1. Not from the original, from 1 to the next, to the next, to the next. Does that make sense? Or no? So from the first to the next, I go up 3 over 1. From that second point to the third, I go up 9 over 1. Are you with me or not so much? You don't have to use the pattern. You could just plug in points if you wanted. So you could, once you get the vertex, you could say, I don't like the pattern. I'm just going to plug in 3 and see what comes out. If you plug in 3, it's going to come out with a -1. So you would get those points anyway. You're just doing it, the work to get them. You do the same thing. You can plug in 2. It's going to come out with an 8 and you can mirror it over to this side. Does that make sense? So if I needed to find these other things, which I do, the axis symmetry is just x equals 4. D, my y-intercept would just be 0.44, right? My x-intercept, I don't actually know where it is. I know an approximation. So I would have to actually solve this one. And this one I'd probably do quad formula on. I don't really have a ton of time left. Yeah, I do. So if I'm going to solve this with quad formula, let's see. -b plus or minus the big old square root 24 squared is 576. Minus 4 times A is 3 times C is 44. All over 2A. That's 528. So we get a 576 minus 528 all over 6. Oh, I'm sorry, I'm off. You guys didn't even tell me. Uh, 48. Now, since I'm graphing, no, all right, never mind. All right, square root of 48, that can split into 16 and 3, right? So that would be 4 root 3 all over 6. And then I can reduce all of those by 2. So there's my answer. It doesn't really help me that much when I'm graphing because I don't know where 12 plus minus 2 root 3 over 3 is unless I turn it into a decimal. But I already have all the pieces I need because we know the formula or the pattern. Connect with a nice smooth curve. Okay, so I know you're anxiously awaiting your homework. Let's do, how about, so I do want you to do A through F or whatever it is, but only for numbers 5 and 7. How about that? Just those two. That's not so bad. Tomorrow we'll touch on the inequalities that we didn't get to, but. All right. It's had like 6 minutes. You could get this done if you're super fast.